Welcome back to the Deep Dive, your shortcut to being truly well-informed. Today, we're diving into something that feels more relevant literally every day, artificial intelligence. More specifically, we're tackling this really crucial question of, well, how do we make AI outputs more accurate? How can we actually trust them?
Yeah, it's something I think almost everyone's run into, right? You ask an AI, maybe a chatbot, a perfectly simple question,
Yeah.
and it just gives you something completely confidently wrong. Like,
Yeah.
that hypothetical you mentioned, asking how to keep pizza toppings from sliding off.
And it suggests industrial glue. Yeah.
Exactly. And the confidence is almost the strangest part.
It really is. It's so sure of itself. And then what gets me is you ask it to try again, and it might even apologize.
Uh-huh. Yeah, apologies.
Right. But then it offers something just as weird. So you're left thinking, okay, what parts can I rely on here?
That's precisely it. And, that's the core challenge we're digging into today. Because if we're going to start depending on AI for important decisions, work stuff, maybe health questions, even just solving everyday problems.
Yeah, the stakes get higher.
They really do.
Yeah.
Its accuracy just has to be, paramount. We need it to be reliably correct, not just creatively wrong.
Okay. So our mission for this deep dive is clear. Explore these powerful techniques that are actually designed to significantly boost AI accuracy. The goal is so that you, listening, can feel more confident. You can genuinely trust the insights AI provides. We've pulled together the key info from various sources to explain the how and why. So where do we start?
All right, let's jump in. The first big technique is something called RAG. That stands for Retrieval-Augmented Generation.
RA, okay, sounds technical, not like something you'd use for pizza spills, I guess.
No, not quite. But it tackles a really common headache with large language models, LLMs. See, they have what's called knowledge cutoff. Basically, they only know what they were trained on up to a certain point in time.
Okay, so if something happened yesterday or it's super niche, the LLM might be clueless.
Exactly. Or worse, it won't admit it's clueless. It'll try to guess. It hallucinates, as they say, give you a confident-sounding answer that's just made up. That's your pizza glue scenario right there.
Gotcha. So RI is the antidote to AI hallucinations. How does it work?
Well, the core idea of RAG is to give the LLM relevant, trusted, external information before it even tries to answer your question. Think of it like having a secure, up-to-date digital library right next to the AI. Usually it's a specialized database, like a vector database, full of verified facts.
Okay, like a cheat sheet, a reliable real-time cheat sheet for the AI.
Precisely. So when you ask your question, first this component called a retriever looks at it. The retriever figures out what your question is really about. Then it goes and fetches relevant documents or snippets of data from that trusted library.
It finds the right pages in the cheat sheet.
Exactly. Then that retrieved information gets seamlessly added or augmented to your original question.
Augmented, right. So the LLM doesn't just see, how do I keep my pizza toppings on? It sees, how do I keep my pizza toppings on? Plus, maybe some real culinary tips fetched from that trusted source.
That's the essence of it. The LLM gets this much richer, more informed prompt. It's now equipped with the specific external facts it needs. And this dramatically cuts down on hallucination.
Yeah.
It massively improves factual accuracy because the AI isn't just relying on its often outdated training memory. It's grounded in current specific info.
Grounded, I like that. It anchors the AI in reality, not just its internal, sometimes weird world.
Yeah. RAG transforms a guessing AI into more of a research assistant.
Okay, that's a really powerful concept. Give the AI the facts it needs right when it needs them. But beyond just feeding it data, does the type of AI model itself make a difference in accuracy?
Oh, absolutely. That's another huge factor. Choosing the right model for the task is critical. It really is like picking the right tool for the job, AI models aren't one size fits all. They vary a lot in scope and what they're good at.
Right, like using a sledgehammer to crack a nut or maybe tweezers to build a house. You'll get a result, but probably not the best one.
Exactly that. So broadly speaking, you have large general models and smaller, more specialized ones, the large models. They're trained on just massive, diverse data sets. Think medicine, law, art, tech, sports, everything. So they're pretty good for broad general questions. Their wide knowledge base makes them less likely to just make stuff up if the question is pretty general.
Okay, so asking a big model what caused the French Revolution or explain quantum physics simply, it's probably got a decent shot because it's seen so much varied information.
Right. But then you have the smaller specialized models. These are trained on very specific, narrow domains. Imagine an AI trained only on say 17th century Dutch paintings.
Okay, very specific.
Very specific. And these models excel when you ask them questions within that niche. They're far less likely to hallucinate there.
That makes intuitive sense. It's like asking a heart surgeon about brain surgery. They might know the basics, but you'd trust the neurosurgeon more for the specifics.
Perfect analogy. The heart surgeon, like the general AI, has broad medical knowledge. The neurosurgeon, like the specialized AI, has deep expertise in one area. So while that general AI might give you a passable answer about 17th century Dutch art, the specialized one could give you incredibly precise details, nuances a general model would totally miss or maybe just invent.
So the key is matching the AI's training, its expertise, to the actual question you're asking. That alignment boosts the accuracy from just general knowledge towards specialized truth.
Precisely. It's about alignment.
That's really clear. Align the model to the task. Okay, what's the next technique we should know about?
Let's talk about chain of thought prompting, usually just called COT.
Chain of thought. Okay, this sounds like it gets into the AI's thinking process.
It really does. Basically, COT forces the LLM to slow down and actually spell out its reasoning steps before it gives you the final answer. This is super helpful for problems needing logical steps, like math problems or complex reasoning tasks. Sometimes LLMs jump to a quick answer that feels right but is actually wrong.
So it's like making the AI show its work, like my old math teacher used to say. Avoids those intuitive leaps that might be flawed.
Exactly that. Let's take a quick example. Say a factory makes red and blue widgets. It makes 3 times as many red ones as blue ones. If they make 240 widgets total, how many are blue?
Okay, hang on. 3 times as many red, total 240. My gut says 80, because 3 times 80 is 240. Wait, no.
See, that's the intuitive jump. It feels right, but is what LLMs often do too. But if you force it to show the steps, let B be blue widgets, then red is 3B. So B plus 3B equals a total 240.
Oh, okay. B plus 3B equals 240. So 4B is 240.
And then B equals
240 divided by 4, which is 60. 60 blue widgets, not 80. Showing the work caught the mistake.
Exactly. That's COT in action. And there are a few ways to trigger it. Sometimes just adding a simple phrase like "let's think step by step" to your prompt, that's called zero-shot COT, is enough to make the model lay out its reasoning.
Just a little nudge to make it explain itself.
Yeah. Or you can use few-shot COT. This is where you give the AI examples in the prompt, not just the question and answer, but the whole step-by-step solution for similar problems. It learns the pattern from your examples.
So it learns how to show its work by seeing examples. That's clever.
It is. And now some of the newer, more advanced models actually have this chain of thought reasoning kind of baked into their architecture from the start. It makes the whole process more transparent, more auditable. You see how it got the answer.
Yeah.
But it's important to note, COT is great for reasoning tasks, but it doesn't really help much for straight factual recall, questions that don't need multiple logic steps.
Got it. Super useful for complex problems, less so for simple facts. Okay, so one AI thinking step by step is good, but what if you could get multiple AIs to weigh in? Does pooling their thoughts help accuracy?
That leads us perfectly into the next technique, LLM chaining. And yes, the idea is basically strengthen numbers or getting a sort of consensus opinion. Instead of just trusting one AI's output, you leverage multiple LLMs. You're drawing on the collective intelligence, if you will, of several models.
Okay, so like assembling a panel of AI experts or maybe crowdsourcing the answer, how does that work in practice?
There are a couple of main ways. One is sequential chaining, sometimes called revise and reflect. Your first prompt goes to LLM number 1. Its answer then gets passed to LLM number 2. Number 2 looks at the first answer, kind of critiques it, refines it, adds its own understanding, and passes that improved answer to LLM number 3, and so on.
So each AI builds on and improves the previous one's work, like an assembly line of refinement.
That's a good way to put it. The final answer benefits from all that iterative feedback and collective input. Another approach is the supervisor-decider model. This is a bit different. You have one main supervisor, LLM. It takes your prompt and sends it out to several other LLMs all at the same time.
Okay, so it delegates the task.
Right. Then it gets back all the individual answers from those worker LLMs. The supervisor then acts like a critic or an editor. It analyzes all the responses, synthesizes the best parts from each, and puts together a final, hopefully more accurate and robust answer.
So it's like phoning multiple friends, hearing all their advice, and then using your own judgment or maybe a trusted advisor's judgment to make the final call based on all that input.
Exactly. It's about different AIs essentially checking each other's work, leading to a higher chance of getting to the truth.
That makes a lot of sense, using multiple minds for a better outcome. Now, you mentioned using multiple separate LLMs. What if you have one absolutely massive AI? Can it have different specialists inside itself?
Yes, and that brings us to mixture of experts, or MOE. This is another clever way to boost accuracy, but it works internally within a single, very large model. Instead of chaining separate LLMs, a MOE model is built with multiple specialized submodels inside it. Each one is like an expert on a specific topic, math, maybe, or law, or creative writing, or coding.
Okay, so it's like one giant brain, but with different lobes or departments that are experts in specific fields. That sounds efficient.
It can be very efficient.
Yeah.
When you send a prompt, there's this thing called a gating network inside the MOE model. Think of it like a super smart router or dispatcher. It analyzes your prompt and figures out which internal expert, or maybe which combination of experts, is best suited to handle it.
So if my question involves math and needs a well-written explanation.
Exactly. The gating network might send the calculation part to the math expert submodel, and then route the results to the language expert submodel to phrase the answer clearly and grammatically. Then the outputs from these different experts are combined to give you the final comprehensive response.
Okay, so it's different from chaining because it's all happening within one big AI, just routing the task to the right internal specialist department.
Precisely. Chaining uses separate AIs talking to each other. MOE uses specialized parts within one AI. Both aim to reduce errors by bringing multiple perspectives or specializations to bear, but the architecture is fundamentally different. MOE lets a single AI act like a polymath, leveraging internal specialization for greater precision across diverse queries.
Polymath AI, I like that. Okay, internal specialists. What else can we tweak? Can we adjust how the AI behaves?
You absolutely can, and that brings us to adjusting the temperature setting.
Temperature, like making the AI hotter or colder. Does it get grumpy if it's too low?
Not exactly grumpy. But temperature does control the AI's output style. Think of it as a knob controlling the balance between predictable, factual answers and more creative, varied ones. The settings usually go from 0.0 up to maybe 1.0 or even higher.
Okay, so low temperature means stick to the facts, and high temperature means get creative.
That's a perfect way to put it. Low temperature, say 0.0 to maybe 0.5, makes the AI more deterministic. Its answers will be more focused, factual, consistent, predictable. Ideal if you need precision, like asking for scientific data, code snippets, or just retrieving specific information reliably.
Right, you don't want the AI getting creative when you ask for, I don't know, the boiling point of water.
Exactly. But what if you do want creativity? Maybe you're brainstorming ideas, writing song lyrics, or drafting some imaginative marketing copy.
Then you turn the heat up.
You got it. High temperature, maybe 1.0 or above, lets the AI take more risks. Its answers become more creative, diverse, less predictable, sometimes even surprising. So the right temperature setting really depends entirely on your use case, what you actually need the AI to do. Are you looking for strict accuracy or imaginative flair? You tune the temperature accordingly.
That makes so much sense. It's not about one setting being better. It's about matching the setting to the goal of your task, fine-tuning the AI's personality for the job. Okay, this is great. Are there any other maybe quicker techniques worth mentioning before we wrap up?
Yeah, two more quick but important ones. First is the system prompt. This is like a hidden instruction that gets added to every single prompt you send to the model. It's set up beforehand, often by the developers. It can give the AI general guidelines on how to behave, like always strive for accuracy or avoid harmful content. It can also set up guardrails to prevent things like undesirable outputs or even prompt injection attacks.
So it's like a little angel on the AI's shoulder whispering instructions in its ear constantly.
Kind of, yeah. A persistent set of rules. The second one is RLHF, reinforcement learning with human feedback. This is huge. It's where humans directly rate the AI's responses. Think thumbs up, thumbs down.
Like rating a movie or a product online?
Similar idea. The human feedback agreeing or disagreeing with the AI's output is used to reward the model for good answers and penalize it for bad ones. This constantly fine-tunes the model over time, pushing it towards higher accuracy based on real human judgment.
So we're essentially training the AI continuously by telling it what we think is right or wrong. It learns from our collective feedback.
Exactly. It's a powerful loop for improvement.
Wow. Okay, we've covered a ton here. From fixing pizza problems with RE instead of glue, all the way to these complex MOE models and human feedback loops. It's quite a toolbox.
It really is. And I think the big takeaway is that there's usually no single magic fix for AI accuracy. The most effective approaches often involve combining several of these techniques strategically. You tailor the solution to the specific problem you're trying to solve, building layers of defense against errors.
That makes sense.
Yeah.
So thinking about all this, for you listening, understanding these techniques really changes how you might look at AI, doesn't it? It stops being this mysterious black box that just guesses sometimes and becomes more like a sophisticated tool, one that we can actually engineer, that we can fine-tune for much better reliability and precision. And that really opens up possibilities, right? How could this level of control, this potential for accuracy, change how you might use AI in your work or your studies or even just your daily life?
That's the really exciting question. And on that note, what stood out most to you listening today? Did any of these techniques spark new ideas? Or maybe found other ways to get better answers from AI? We'd genuinely love to hear your thoughts and suggestions down in the comments.
Absolutely. Your insights really help shape where we go next. And of course, if you found this deep dive valuable, if you want to keep getting the shortcuts to being well-informed, please do show your support. Give us a like, definitely subscribe to the channel, and maybe hit that notification bell so you won't miss our next deep dive. And please share this with anyone else you know who's curious about how AI actually works under the hood. Because, sharing knowledge and sparking those aha moments, that's really what this is all about. Thanks so much for joining us, and we'll see you next time on the deep dive.